Welcome to this session of 5th International Symposium on Multidisciplinary Studies and Innovative Technologies. My name is Emir Köksal. I'm a professor doctor in the Department of Mathematics at 19 Mayıs University. We have 5 presentations in this session. The duration of each presentation in...
I don't think it will create a problem.
Excluding question and remark. I think the first 2 speakers are absent. Boris Kostov is absent. Third speaker is also absent. Okay, we continue by Elia Nor. The title of her talk is Development of Quadrature Control Under Wind Disturbance.
Excuse me, Doctor. I am the third presenter. Excuse me, paper ID
Okay.
75.
Okay, sorry.
Yeah.
Okay, you can start.
Okay, thank you. Is that okay? You see my screen?
Yes, we can see.
Okay. Thank you very much. Actually, I would like to start my presentation. Thank you. First of all, I thank you very much for giving me the opportunity to present my presentation here. My paper ID is 75. Here it is, the authors. The speaker is Donia Aziz. So I'm going to present on behalf of the authors. The topic is the recent advances in IoT-based smart plant irrigation systems. I'm giving a brief review. The presentation is, I'm going to go over the presentation according to the outline given here, which is the challenge and trends, background, watering importance, and autonomous plant watering system, and giving conclusions. Actually, oftentimes persons forget to water their plants throughout their daily duties. That's make it difficult to keep their plants healthy and strong. In such a situation, we always would like to to solve a problem and to overcome such a situation and promote plant development. Automatic watering system can be a perfect choice for such a situation. That's why I'm going to over the irrigation system. Even we can call it irrigation system or watering system. So it is a conventional technique that employs a greater percentage of workers in agriculture in daily basis. That can be happened or can be fulfilled by using sensors and microcontrollers that would be used to detect when the groups or the plants have to be watered periodically. That can increase the manufacturing speed and lowering the costs. The basic purpose of the system is correct programmable model that can be automatically water the plant and provide information on the agriculture or any other environment. So that's why in this work we are going to give or analyze the different kind of irrigation systems with respect to their benefits and demerits based on different kinds of microcontrollers and sensors that can make the cost higher or the design complex. That's why I'm going to use my system on Internet of Things. Often we call it Internet of Everything, which is a paradigm that inventions the worldwide network with interconnected equipment and gadgets. In such a situation, we call smart gardening based on Internet of Things or smart farming. It's the process that remotely serving the status of the farm on garden and automating it. That's why gardening is the pleasurable hobby that needs attention in order to keep plants healthy and strong and with good health. That's why in such a situation, due to the all the time changeover in the weather and in the situation of the weather and climate, that's impossible to be under a constant observation for a whole day. That's makes the current real world mechanisms being equipped with brains and processing power in order to develop the plant or the system correctly. The shortage of the water is considered a great major problem in today's fast-paced world. That's why we thought that watering automation system based on IoT aims to connect as many devices as possible over the internet. There are many kind of difference of factors that we have to thought when we try to design a system, a control system that can automate with the gardens or smart farming. We talk about herbs, soil, and climbers, and there isn't enough power to handle with these plants to give beauty to the environment. That's why we have to think about different kinds of sensors, the sensors that can handle with soil, moisture sensor, that are the method that could fulfill the soil to provide the water when it is needed. In addition, the other factors like temperature and humidity can play a significant role to impact the harvest progress. That's why we always think about temperature and humidity that effect on the soil and to keep it healthy and the plant to keep it strong. Here I'm going to show a different kind of autonomous plant watering systems in the sequences figures that are shown here. Again, we will return back to water shortage. It's our big problem that could be always thought about. So to address this issue, a system that uses water wisely and prudently is required. So there are a variety of plants is sensitive to water. So in order to get proper growth, health, and overall development. So the watering plant is the most important duty in the gardening nowadays. Regarding of the weather, we know that everybody would like to be able to control the amount of water that arrives to the plants, to their plants and groups. Here I'm going to show a summary of the presented works. Actually, all the works are given are using sensors similar to each other. Soil moisture sensor, DHT, which is temperature and humidity, pH sensor, and so on. However, the differentiation will be in the microcontrollers. So we know that there are different kind of microcontrollers, like nowadays as a modern microcontrollers, which is Raspberry Pi, Arduino, and so on. However, Raspberry Pi we can deal with complexity in the code, in the coding part, and for Arduino it's perfect board. But we have to think to make an integration with other kits in order to, for example, with Zigbee, with the Ethernet shield, in order to create the Internet of Things and make it effective. So we think always about Node MCU, which is a kind of it is Arduino integrated with ESP8266, which has already integrated with Wi-Fi, so we can deal with IoT similarly. However, the most great problem in such an integration is the ports number of the analog ports is limited. So as some authors here are making a integration with Node MCU and Arduino, that's making the cost high and the complexity higher. Always when we have Arduino, we have high cost and complexity higher. However, with Node MCU, if it is needed, the complexity is no complexity and with lower cost. However, we can replace this Node MCU ESP82 with Node MCU ESP32 because we have it is providing a good number of analog ports. So that's why we suggest to replace between these two microcontrollers. Here I'm going the conclusion. The microcontrollers analysis and links with interconnected to detect the sensors and the outputs coming from the sensors to make data collection. Various plans characteristics were observed and related study utilizing technologies such as GSM, Zigbee, and Bluetooth. Both have their disadvantage. After analyzing the literature, we can get the concept that integrating with newest technology in order to get modern farming technique. The requirement for such a modern system, we need to deliver water just to those places that when it is needed. So the most important part is the wise choose for microcontroller. As I said, when we choose an Arduino with Node MCU together, we can get some complexity and higher cost. So we have to choose the microcontroller in a better way to reduce the complexity and the cost. And thank you. If you have any question, I would be grateful to answer.
Any question, comments, or remark? No question. Thank you very much for your presentation. Yes.
Okay. I just have one question because I'm interested with the IoT based gardening, because I'm also doing my gardening. I'm actually finding a way how to make the automation system for my garden. So which one have you tried develop any of the using any of the microcontroller for the gardening for the whole system?
Yes, actually, I suggest to use Node MCU ESP32 because for the other one, we don't have analog port inside. So it is difficult to deal with the sensors that got more than one analog port. So I suggest to use Node MCU. Actually, we developed some kits based on Node MCU ESP32. Yeah.
So is that reference of paper 19, is it? Paper 19.
Actually, we are working over, so we will publish maybe in this month, inshallah. Yeah.
Okay. All right. Thank you. That's very interesting.
Thank you.
Okay.
Any other questions, please?
Thanks again for your presentation.
Thank you so much, sir. Thank you.
Next speaker is Elia Mohtnor. The title of the talk is Development of Quadrature Control Under Wind Disturbance.
Okay. Let me share my screen first. Sorry. Okay. So can you see my screen, everyone?
Yes.
Okay, thank you. Okay, Assalamualaikum and very good morning. I think in Turkey it's morning, right? So I'm in Malaysia. We are actually in the afternoon, in the evening. So I'm here today to present this work. The topic is development of quadrature control under wind disturbance. So I'm Ilya Muhammad Noor. So in this research is a teamwork of myself and my FYP final year project students, Nurul Ain Humaira Hasnul Hadi, and also my research grant team. Okay, so we are from Department of Electrical and Electronics, Faculty of Engineering, National Defence University of Malaysia, or in a short form, it is UPNM. So this is the contents of my presentation today. So basically, the work here is focusing on UAV, unmanned aerial vehicle, and we are focusing on quadrotor UAV. So what is a quadrotor UAV? So basically, there are two types of UAV, which are fixed wing and vertical takeoff and landing vehicle. So quadrotor is one of the VTOL families, which is a vertical takeoff and landing. Generally, quadrotor UAV is a type of aircraft with no human on board. It was operated by remote control and fly autonomously with the combination of onboard sensors and controlled by the embedded system. Nowadays, quadroto has become a great interest and popular in worldwide. It has greater advantages in terms of high maneuverability and multi-purpose application. So due to this, the quadroto is in high demand and has because of its potential application in the industry. So example application of quadroto is in the search and rescue operation, where human presence is hazardous, such as floods or other natural disasters. In this regard, the quadroto come to be very beneficial in term because it has the capability to hover at the low altitude. At the low altitude and landing at proximity areas. I think my slide is not moving, right? Okay, at the low proximity areas. Okay. So the research motivation, the motivation of this research are three things. First is there are the disturbance winds for the quadroto system, for the quadroto vehicle itself. The wind disturbance degrades the stability of quadroto during flight. So based on the regulation standards by the Department of Civil Aviation, or we call it DCA in Malaysia, UAV or quadroto UAV with small and weight less than 20 kilo can fly up to a certain height without permission approval with maximum altitude of 400 feet above the ground. At this level, allowable flight is actually a troposphere level of the atmosphere, in which at this area the wind is unpredictable. So it is an unpredictable wind gust appear at this level, which give challenge to the quadroto to fly. Secondly, the limited onboard energy to overcome the wind also has also are one of the main challenges that we are addressing in this research. As the quadroto UAV flying in windy environment, the actuators will operate vigorously to control and maintain stability at the desired altitude. Therefore, the battery will drain faster and it will deteriorate the performance of the quadroto. So therefore, based on these two problems, we propose an effective approach to estimate the performance of quadroto under using wind estimator. Okay. So there are three objectives. There are actually two objectives in this research. First is to design the wind estimator from actual flight data using black box techniques in MATLAB. And second is we validate the performance of the wind estimator that we developed using compared it with the actual flight data. Okay, so in this study, in this project, we are using the actual flight data that we obtained from this experimental setup, where we have the actual quadroto that is flying, and then it will experience a turbulence wind that we create from the wind tunnel. So based on this result, okay, we design the some flight procedure where the flight environment, the data that we collected, we focus on two flight environment, which is on moderate wind and strong wind. And the quadroto here that is hovering, it starts from 0 here and it take off and hovering at 2 meters above the ground here. So this is example. This is just to get the feeling of the so just to get the feeling of the flight data that we obtained from this study. So this is from the experimental setup, from the flight operation, we obtained the flight data, and this is one of the examples. We plot it in MATLAB. So it is a three-dimensional flight data where it has the x-axis here, Y and Z. So as you can see here, the wind is the wind from the turbulence from the wind tunnel give the turbulence wind that that pushing that from this direction, and the quadroto UAV is trying to hovering at that position, at this position with the challenge from the turbulence wind. So based on the flight data, we plot it, and this is what we obtained. So this one makes sense, as you can see here, there are some some diversion from the position, from the desired position here, which is due to the turbulence wind. So details about this flight data, this setup, this work is in you can refer to my paper on the evaluation of rotor flight and battery consumption under wind turbulence condition in an open jet wind tunnel, which is published in 2021. So, for this work that I'm presenting here, okay, based on the flight data, the actual flight data we obtained, we are designing a wind estimator using a black box, which is a transfer function in MATLAB. So this is the framework of the wind, the development of the wind estimator. So based from the actual flight data, we have normal procedure, we do the data identification and then data processing, and we divide the data into two parts: estimation data and validation data. So the estimation data is the one that we insert it into the black box toolbox in MATLAB, and then we validate the model, okay, where we compare it with the validation data and we analyze the performance. So let's see the results. So this is the results from the actual data. We are focusing on in these presentations, I'm focusing on the results for position Y, where the quadrotor, if you see here, there are two data here, which is moderate wind and also strong wind. The quadrotor's flight from the moderate wind, which is the blue color, and the quadrotor flight from the strong wind, which is the red color. So this is the position Y. So as you can see here, the operation during the UAV experiencing moderate wind, when it's takeoff, it is the position error is 0.000447, and during landing, the position supposed to be at 0, but it has an error of 0.015. So the error is within this range, which is the average error for during the moderate wind. Okay, the average error of the UAV from the desired point is 0.014 for the moderate wind when it experiences a moderate wind, and the average error when it experiences a strong wind is 0.054. So which is this one represents the actual flight data. So you can see here, this is the actual flight data from the wind tunnel in terms of two-dimensional, which is X, Y position over time. So this is what it means here, the position error of 0.014. We look at it's supposed to be the UAV, the quadrotor supposed to hovering at the desired point, which is 0, but it is shifted an average of 0.014 here due to the wind, due to the moderate wind, and this one also it is shifted at 0.054 here due to the strong wind. So the strong wind experience higher deviation in position Y compared to the moderate wind. So the if you can see here is that the increment of the steady state error between the moderate wind and the strong wind is 67%. It means that strong wind has 67% higher position error compared to the moderate wind. So this is again we look at the actual flight data for position Y with how the control top performs during this position control. So this is, if you can see here, the blue one is the moderate wind, and the torque here, the second graph is the torque, is showing that the torque for the moderate wind and also the torque for the strong wind that controls the four rotors of the quadrotor, so that the quadrotor UAV able to position at the desired position. So now we look at the result of our result when we design the wind estimator. So this is the result of wind estimator using black box techniques. So we just here is the the screenshot of the some of the plant identification progress, the black box techniques that we use just to get some feelings how we get the data, how we get the result. So this is the result of strong wind, which is 94.93893, and then this is the results of the fit estimation using moderate wind. So if you can see here, the types of wind for moderate wind, it is 63.01, and the strong wind is 94.93, and this is the transfer function of the wind estimator for the moderate wind and the using the moderate wind flight data, and this one is the transfer function of estimator using the strong wind flight data. So this is the simulation for the model. So we have the, you can see here, this is the model of Quadroto that we use in MATLAB to study, to analyze the performance of our developed wind estimator with the actual flight data. So, and this is the moderate wind and the strong wind that we already developed, designed, and the transfer function that we developed in the design stage. So now we go to the simulation of Quadroto with wind estimator. So if you can see here, this is the position Y and time, the simulation of Quadroto with wind estimator. This is the time from 0 to 1000 seconds. So we hardly see anything. There is actually something around here. So we zoom it at this range, which is from 50 to 500 time. And then we zoom the position Y. You can see that the strong wind, it gives a higher, larger overshoot using the transfer function of the strong wind, and we input some flight data. So it shows that the output from the transfer function using strong wind, it gives the highest, high overshoots, large overshoot, and it has large steady state errors as compared to the moderate wind. So from the results, we did a few studies. We performed this studies analysis using other flight data just to strengthen the results. So in the end, this is what we get. So from the type of wind, using the actual flight data, as we mentioned previously, in the first stage, we have 67% increment of position Y when from the strong wind compared to the moderate wind. So it means that when the wind is strong, so the position error for the Quadroto UAV experienced 67% higher deviation compared to the moderate wind. And when we did the development, the wind estimator development using transfer function in MATLAB, MATLAB toolbox, black box technique, using black box techniques, we discovered that we obtained the steady state error for the moderate wind is around 0.99, this value, and the strong wind is around this one. And if we compare it, looking at the relationship between both, we able to get that the strong wind has 70% higher steady state error compared to the moderate wind using the black box, using the model that we estimated using black box techniques. So what we can conclude here is that the variation of the steady state error of position Y between the actual flight data and also the wind estimator that we developed is just about the 3%, which is acceptable, we find it acceptable. So that's all. As a conclusion, we conclude that the development of Quadroto control under wind disturbance can be achieved by simulation of Quadroto using wind estimator. Thank you.
Thank you very much for your presentation. Any question, comments, or remark? No question. Thanks again for your presentation.
Thank you.
Last speaker of this session is Samuel Adamu Abubakar. The title of his talk is Numerical Investigation of Cbm Recovery and CO2 Sequestration. Samuel?
Yeah, Nur Hocam,
Okay.
he's going to upload. Thank you for your invitation. Thank you. Good morning, by the way.
Okay. Good morning, all. It's a great privilege and it's an honor to be able to participate in the 5th International Symposium on Multidisciplinary Studies and Innovative Technology. My name is Samuel Adamu Abubakar. I'm being supervised by Assistant Professor Dr. Saad Jambola. And today's topic is going to be numerical investigation of enhanced coal bed methane recovery and CO2 sequestration. So this is the outline for today. We're going to look into the introduction and what it entails, statement of the problem, methodology and what it entails, result and discussion, what it entails, and then finally the conclusion. So introduction. Figure 1 shows conventional, unconventional hydrocarbon resources. These are two different separate set of resources that can be extracted. And the difference between conventional and unconventional resources has to do with mostly the ease of extraction. Conventional resources tend to be easier to produce. They are generally targeted first by industry activities, while the unconventional resources are much more difficult to produce. Some of these resources are trapped in reservoir with low porosity and permeability. That is to say, it is quite difficult for the natural gas to flow through the pores very easily. What is CBM? Coal bed methane are unconventional form of natural gas found in coal deposit or coal seam. In recent decades, it is an important contributor to energy production, mostly in countries like United States of America, Australia. China is catching up, where the majority of the country natural gas comes from coal seam. Coal bed methane production involves producing the water that is in the coal click and fracture to reduce the coal pressure up to the methane desorption pressure. This allows for desorption of the methane gas from the coal micropores and click surface so that the methane can be produced. What is enhanced coal bed methane? Enhanced coal bed methane is the injection of gas, be it either carbon dioxide or nitrogen gas, into the coal seam. This helps in producing more methane gas that would otherwise have been inaccessible. So the unconventional coal bed methane production method, which also serves as a method of carbon sequestration, involves the injection of liquefied gas, like I said, a carbon dioxide, nitrogen gas into the coal, which is preferentially absorbed by the coal. Because of this preferential absorption, rather than depressurizing the reservoir to allow for methane desorption, the methane gas is released as CO2 or nitrogen gas is injected as a kind of exchange between them. Normally, coal bed methane produce up to about 50% of the available methane from a coal seam, while injection of carbon dioxide or nitrogen gas increase this production to about 90%. That is to say, for example, if you have a Coca-Cola bottle with the liquid inside, and when you shake it and you open it, it rush out, and then with time the pressure decline. But let's use Mentos as our gas, either CO2 and N2 or nitrogen gas, and you throw it into there, the pressure will increase. It will increase and it will sweep out the remaining Coke, the remaining liquid in the bottle. So that is to say, it increased the production of it. So carbon sequestration. Carbon sequestration secure carbon dioxide to prevent it from entering the earth's surface. Although carbon sequestration can occur naturally, this process is slow and geological sequestration is needed in order to effectively reduce carbon footprint. Using carbon dioxide as injection gas is apparently a win-win situation, as more methane gas can be produced while CO2 is stored underground. And statement of our problem: the Oyema Kobe field in Nigeria, in Enugu, Nigeria, is an oil mineable coal field. We use this as our case study to investigate the use of coal bed methane and CO2 enhanced coal bed methane method of producing in this very field. Different well orientation were presented to find which performs best or better in terms of carbon sequestration and methane production. Methodology of this Oyema coal bed field: the Oyema coal bed field in Enugu is an unminable coal, like I said. The characteristics of the field will be shown in the next slide. 10 different cases were used to create this model on CMGGEM, which include 5 coal bed methane and 5 enhanced coal bed methane. The created models was then made to run on CMGGEM for 10 to 15 years, starting from the 1st of January 2020 for the production and injection until it reached its economic limit. After the economic limit was reached, the injection was continued for enhanced coal bed methane cases for 10 more years. Other than the first case, which was run for 15 years, all other coal bed methane cases were run for 10 years before they reached their economic limit and production was stopped. While for enhanced coal bed methane cases, they were run for just 15 years with injection of CO2 and production of methane gas at the same time before they reached their economic limit, and then production was stopped. After this economic limit was reached, CO2, that is carbon dioxide, was sequestered for the next 10 years in the reservoir. So these are the parameters that we use to create our model on CMG GEM. So this our well, how we set our well for case 1. For case 1, we have 2 vertical well producers, while for case 2, we have 2 horizontal well producers, and case 3, we have 2 horizontal producers and 2 vertical injectors, while for case 4, we have 2 horizontal producers and 2 horizontal injector, while case 5, we have 5 vertical producers. Case 6, we have 3 horizontal producers. Case 7, we have 3 horizontal producers and 3 vertical injectors. Case 8, we have 3 horizontal producers and 3 vertical injectors. Case 9, we have 4 horizontal producers, and case 10, we have 2 vertical injector, 2 horizontal injector, and 4 horizontal producers. So these are the details of the 10 case applied on CMG GEM. Then the result of coal bed methane recovery operation are dependent on the absorption and desorption of methane. This desorption and absorption of methane to coal is determined by the Langmuir isotherm, in which amount of gas at pressure equals to a Langmuir volume parameter all over Langmuir pressure parameter plus pressure. So to investigate this scenario, three cases. Case 3 was subjected to 3 different conditions, that is high pressure at 2000 psi, medium pressure at 800 psi, and 36.26 psi at low pressure. It is important to note that case 3 was originally investigated at low pressure, that is 36.26. The pressure conditions were set in the reservoir by setting the constraint of the producers to have minimum pressure equal to the desired pressure condition. So after this, running these simulations revealed that the relationship between pressure and volume absorbed of adsorbed gas is directly proportional. That is, at lower pressure, there is low amount of gas adsorbed to the core and vice versa. In respect to, this is in agreement with Langmuir isotime equation. This means that the lower the pressure in the core bed methane reservoir, the more methane can be dissolved from the core and be produced. At higher pressure, however, there is a high limitation on the amount of methane that can be dissolved from the core. So this is the cumulative gas production with time for all the 10 for all the 10 cases. This is the graph generated from CMG, and then this is the cumulative carbon dioxide injected with time. Same generated from our graph CMG. So adsorbed, this is the amount of adsorbed methane at the beginning of the life of the case 10, because as we run our simulation, case 10 perform better in terms of methane recovery and CO2 sequestration. So this table shows us the best in which case 10 come first with 95.2 recovery factor and 8.68 cumulative methane recovery, and then case 7 comes second, and then we have case 8, and then and so on. So in conclusion, in the choice between conventional coal bed methane and CO2 sequestration and CO2 enhanced coal bed methane for producing from unminable coal bed reservoir, it was seen that CO2 enhanced coal bed methane generally perform better in terms of gas production, with the best case for CMB producing less gas than the best case of CO2 Is Cbm. It was seen that large amount of CO2 could be sequestered into the Oyema coal bed field in Enugu, Nigeria, without reaching the reservoir fracture pressure. And this show potential use of CMB in Nigeria as a method of carbon sequestration and storage to make up for the large volume of flare gas. So subjecting the reservoir to high pressure condition lead to low gas recovery because of most of the gas stays absorbed to the coal surface. On the other hand, subjecting the reservoir to low pressure condition lead to higher gas recovery, since small desorption can occur under this very condition. So, thank you.
Thank you very much for your presentation.
Thank you
Is there
very
any
much. Sir.
question, comments, or remark? No question. Thanks again for your presentation.
Thank you very much, sir.
So now I am ending up this session. Thanks again for your participation to this international symposium.
Thank you very much, sir.